In any data collection effort, it's very important to get good data. Since we can't often measure or survey an entire population, we have to talk about how to get a sample. So in the next several videos, we're going to talk about different sampling strategies, different way of collecting sample data. I'm going to pretend that we have a scenario where we're going to try to get data from these breakfast cereals. So this, I want you to pretend, is a set of shelves in a grocery store, and this is our population. This is the total amount of cereals we want to learn about. This is all of them. And our goal is to study nutritional information of cereals from a sample. We don't have time to study all of the 28 cereals in our population, so we're going to take a sample. In the next several videos, we'll use several different sampling strategies. In this video, we're going to focus on what's known as the simple random sample. A simple random sample is a sample that's selected so that every sample of the same size has the same chance of being selected. So, I need to convince you that there's a way to pick some cereals from this set of 28 so that every possible sample of the size we choose has the same chance of being selected. We tend to use a little n to represent a sample size, and in this example, I'm going to choose a sample of size 7. So I'll need to convince you that I can choose these breakfast cereals in such a way that every sample of size 7 has the same chance of being selected. So here are our breakfast cereals on their shelf, but spread apart so that we can actually grab them and sample them. And so we call this a simple random sample, and the randomness part kind of makes sense, right? Because I need every single sample of size 7 to have the same chance of being selected. One of the nice consequences of that is that every cereal will also have the same chance of being in our sample. We call it a simple random sample because the easiest way to think about it is to simply put all of the cereals in a hat, or here in my math coffee mug, and then we'll draw 7 out after we've mixed them up. So we're going to take all of our cereals. We're going to mix them up so that we're not picking them in any particular order. And then we're going to draw 7. So I'm going to take them off camera and shake them really well, mix them up very well, and draw 7 of them. All right, so here we go. 1, 2, 3, and I'm shaking in between just to emphasize that I want this to be randomly done. 4, 5, 6, and here's our 7th breakfast cereal. Here's our sample of size 7. All right. So now I need to convince you that every cereal that was in the coffee cup actually had the same chance of being selected. That all 28 cereals could have ended up in my sample. So I have them all here, and the first thing I did was I stuck them in my coffee cup, and I think we can all agree that with 28 cereals in the cup, when I picked one out randomly, that had a 1 in 28 chance. I shake them up again, and the next one has a 1 in 27 chance. And every cereal that was still in the cup has that same chance of being selected. And that means that each sample of size 7 has the same chance of being selected. Now, to actually verify that, we would need to discuss some topics from probability that'll come up later in our course. But if I was going to make one connection here, is that when we see simple random sample thrown around, we're going to think of things being drawn out of a hat. Or a coffee mug. Most people say hat. So we'll go with hat. All right, so that's a simple random sample. Just drawing names out of a hat. Every sample of the same size has the same chance of being selected. Now, some textbooks call this a random sample instead of using the adjective simple in front of it. we don't need to be very hung up on the distinction between random and simple random, but I do want to just say that those are different things. In a random sample, instead of every sample of the same size having the same chance of being selected, the only requirement in a random sample is that each element has the same chance of appearing in your sample. So one way to generate a sample of size 7 would just be to take one of these rows. So instead of putting all 28 things in my cup, I could just put the numbers 1 through 4 in my cup. Shake the cup and draw a number out, and then that row, 1, 2, 3, or 4, becomes the 7 things in my sample. And in that sampling strategy, every cereal has a 1 in 4 chance of being in the sample, but not every possible sample can happen. I can only get this row of 7 things. I can't get 7 things that are made up from different rows. So in a simple random sample, every sample of that size has to be possible, and they all have to have the same chance of being selected. And we can think about that just by drawing elements from our population out of a hat or a coffee mug.